kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
Bank 1 completed.
MRO has lost log.
Probably indicate reversal, bank reversal.
We have indications that press reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Doppler indicate reversal. Bank 2 complete.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
Probably reversal.
End of range control, range minus 1.9 kilometers, cross range minus 2.4 kilometers.
Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, but to the target on Mars, but instead is flying straight to the target. Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO is reporting good telemetry log.
We are coming upon the
start.
We are starting the straighten up and fly right maneuver,
UBMD jettison,
where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Doppler indicate chute deploy.
The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct-to-Earth tones.
As expected. As expected.
Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Oh my God. Oh. Oh.
MRO reports they're still getting telemetry from the lander.
All right, all stations.
We got it.
Touchdown confirmed. We're going to wait for the images.
Wow.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
That'd be great.
So much has been riding on this.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
It's not the
Flight, we have seen the completion of EDL 3000.
Copy activity. That is as expected.
MRO is still seeing a strong signal from the lander.
News in, it looks like we're getting the first image. Here, take a look at the first image.
Flight, this is OL3. I have the target point on the map when you are ready.
We are ready, OL3. Go for it.
Flight, I'll be moving in, showing you the safe zone that we've landed in.
The team has just put the first image from Perseverance on the surface of Mars. Now, it comes from the engineering cameras, known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
Look at that, right? You get the safe.
Wow. Let's see our engine. Nice. This is amazing.
Here's Andrew.
For Steve. Stand by for Steve.
You did it. You did it. You did. You led the team. You made it happen, man. Congratulations,
We just got our second image in. Our second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close.
This is expected. The communications link we have through satellites to Orion is momentarily lost, but Orion continues to receive and process data. Its computers can handle 480 million instructions per second. Imagine you are traveling with Orion as the flight test continues. One orbit completed. Time to go. The upper stage of the rocket fires again. Like the setup for a roller coaster ride, this is the big climb we've been waiting for. We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home. The upper stage of the rocket triggers separation. Orion's jets fire to turn it into the proper position to re-enter Earth's atmosphere. No matter what happens now, we're coming in. 75 miles above Earth, the spacecraft enters the atmosphere. Things happen quickly. We're now traveling more than 20,000 miles per hour. Air particles pushed out of the way heat up. An envelope of hot plasma surrounds the vehicle as it plummets towards Earth. The plasma reaches temperatures of 4,000 degrees Fahrenheit, almost twice as hot as molten lava. This may be the most dangerous part of the flight. Mission Control is monitoring all the data from the spacecraft, and then we lose communication again. No data can penetrate the plasma. Orion is on its own. Orion is inside a fireball. Onboard systems ignite jets to keep the ship pointed correctly, so the specially constructed heat shield takes the full brunt of the inferno. This is the largest heat shield of its kind ever made. Orion's computers command the spacecraft to bank like an airplane, keeping a precise path to the landing site. Even though we've slowed from 20,000 miles per hour to about 300 miles per hour, we're still traveling amazingly fast. We must slow down to safely land in the ocean. Luckily, we have parachutes. Specially designed for Orion, the parachutes help us hit the brakes, but not too quickly. One day people will be aboard, so deceleration must happen in stages to keep things comfortable for the crew. The forward bay cover jettisons. 2 drogue chutes deploy and slow the returning spacecraft down to 175 miles per hour. Then, the 3 main parachutes open. Once fully engaged, this canopy would cover an American football field. It takes parachutes this size and strength to slow our descent to 20 miles per hour, and then splashdown. For this first flight, we won't have astronauts inside, but we still have some very precious cargo. The flight data from this mission is stored inside the Orion spacecraft. While our flight might be over, there is still a lot of work to do. Onboard sensors recorded every detail, from launch to flying in space, to re-entry to landing. Flight tests are difficult and complex, but they give us confidence that the systems we have designed work under real flight conditions. It's great to be a part of this first space flight for Orion, and we're looking forward to beginning a new chapter in human space exploration.
Signs of past life on Mars. All that can't start until we get Perseverance safely to the ground, and then that's when the real mission begins.
Amount of slipping once we're traversing on the surface of Mars.
Here in the front of the rover, we have the sample caching system. And of course, at the very front end of this is the robotic arm, which this entire system is arguably the most complex robotic system we've ever sent outside of Earth. Here at the tip of the arm, we have a turret which contains a suite of instruments along with some drills and coring capabilities that will allow us to do contact science once we get to the surface of Mars. Not only that, this robotic system is equipped to collect samples about the size of a piece of chalk that then eventually will be stored inside of the vehicle and dropped off in a later location so that an eventual mission can go and return these samples to Earth, something we've never done in the past. Here in the front, we have the remote sensing mast. Something of note is that this mechanism is going to be stowed upon the touchdown on the surface of Mars. And one of the first critical activities we do is deploy this mechanism. This mechanism includes several cameras that are going to give us some of the most breathtaking images we've ever taken on Mars. Along with that, we have some lasers as well as a spectrometer. They're going to allow us to do some remote science. Here you see some of these extrusions that are part of the larger weather suite of instruments that will allow us to characterize the local climate around Perseverance. So that's a quick tour of the rover, but I gotta get back to work. So back to you.
We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight tests at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Oh my God. Oh. Oh.
MRO reports they're still getting telemetry from the lander.